Hi guys, Dr. Luster here, and today I want to start our series on blood sugar and what it is with the very first video of what does normal look like, right? So this video I hope will be a good reference for as we go along, so you can come back and say like, you know, from some of the hyper videos or the hypo videos and say like, this is how it's supposed to work. This is how this one's working instead. So hopefully it'll be a good reference. So normally blood sugar comes from food, right? And your body has different stores of it in terms of glycogen and fat, but specifically it comes from food, and we're going to keep it simple and say that we're only going to mostly deal with the glycogen aspect because it just gets a little complicated, too much for one video. So as you eat food, you get blood sugar, right? So your body comes and breaks it down in your digestive system, and it breaks it down into glucose. And glucose is the most simple form of sugar that your body can process. And so it breaks it down into that. Now, how quickly it does that tells you whether it's a simple carb or a complex carb. So simple carbs mean that it breaks it down super quickly and it takes next to no effort for your body to break it down. Complex carbs take some effort, so you actually have to burn some carbs or burn some sugar to get some sugar, basically. So the yield, the amount that you come out positive, is actually less with a complex carb. Now, in caveman days, that was not super ideal because you were looking for fast energy, right? So if it would be pretty uncommon for you to find, like a great example would be fruit, right? So fruit would be something that you'd be super excited about as a caveman because it's seasonal for the most part, right? And it's super sweet and it gives you that sugar rush pretty quickly, which was ideal for them because they're looking for a fast type sugar a lot of the time. So if you're running from a bear, we want sugar to be available rather than if you are just chilling at home, that kind of thing. So that goes a little bit more into the glycogen versus fat, but that's not where we're going with this. Simple carbs used to be a really, really good thing, and complex carbs were a little less common because of also because just they take a little bit more to generally get to, and you would get them. Some of them you get from plants, some of them you get from nuts, that kind of thing. So it just kind of beans. So it just gets a little bit complicated along that route. So let's just keep it simple. Simple carbs are, for a caveman, fantastic. For us now, who most of us don't have trouble getting access to food the same way, you know, like healthy food maybe, but food in general, especially here in America, we don't have access or problems getting access to food the same way. So simple carbs become this problem because now the body doesn't have to do any work to break down these, and we also are in a society in general that tends to be more sedentary. We sit a lot, and we don't get out in the sun as much. We don't exercise the way we need to. All of those things, and there's just a lot of dysfunction going on. So it becomes more important for complex carbs to be more prevalent because they break down slower and they prevent your blood sugar from spiking, and they require energy to burn them. So today, for sake of ease of explanation, definitely complex carbs are the way to go over simple carbs, but we'd have to go into a different conversation as well as to what are complex carbs and what are the sources, and are those sources actually good for you. But for now, the simple carbs and the complex carbs, they both break down into sugar. And so when you have this sugar, at the very simplest glucose, it is absorbed through your gut and on the other side of your gut is your bloodstream. So it goes through your gut and into your bloodstream, and your bloodstream can now utilize this exactly as it is, and every single cell in your body can utilize glucose, which is why it's so important. But the problem is there is no stop gate or whatever to block glucose from going through the gut. So the more glucose you eat, the more simple carbs or carbs that you eat, the more sugar is going to go through the gut and into the bloodstream, and until it becomes like a saturated situation and your blood sugar is too high. And so now some of it's going to end up going through your gut and going all the way out, but your gut is not designed to do that. So it really truly absorbs most of the glucose that comes into your system. So then if all of it's going to be absorbed, if that is the dominant primary pathway of all of that, then it becomes super crowded in your blood vessels, right? Because even though all of your cells can utilize these things, there should only be so much in the hose, in the bloodstream, right? So again, this is the normal video, so I'm trying to keep from that. So there's so much glucose that is circulating normally in your bloodstream, and that glucose spikes up a little bit when you eat something, and the more you eat, the more it spikes. Depending on the more carbs you eat, the more it spikes. But then it kind of lowers again and falls back as it's being utilized. So you eat it, it comes into your bloodstream, and then that glucose is absorbed by a bunch of cells because insulin comes out and says, hey guys, free for all, time for dinner. So then cells come out and they absorb all of this glucose that they need, and the blood sugar drops, right? So then insulin goes away and says, dinner's over, and the cycle repeats itself next time you eat, right? As a general rule, there are other exceptions to that, like let's say if you are starving, that kind of thing, but we won't go into that. So as a general rule, every cell uses those things, and that's how blood sugar goes up and down. But then again, you have these exceptions, which are what we're going to talk about as to what happens when insulin doesn't work, when it doesn't tell you that there's dinner time, what happens when there is too much blood sugar in the system. So the cells already got everything on their plate that they need, but there's extra. Now what do we do? So there's a whole bunch of different ways that this can go wrong. Also, to throw this in there, for the most part, your kidneys should never let out glucose. They are not designed to get rid of glucose because your body needs glucose more than anything. So when your system is starting to pee out glucose, then there's a problem. So let's say, for example, you go get tested for diabetes, and they want to take your urine for that, and they tell you that there is sugar or glucose in your urine or ketones in your urine. These things become problems because we're talking about how your kidneys are getting damaged because the filter is letting out things it shouldn't be letting out. So for the most part, glucose comes in through your gut without issues, absorbed by every cell in your body to fuel it, and then and it stays in your system and is utilized like that, and it should not come out through your urine. I hope that clarifies just a little bit of how that system works on a normal. It's very, very simple, very easy. And excuse my cat cameo. And it will explain a little bit more on the complications and what happens in the next video. Thanks, guys.